All right, so one little follow-up to our graphing exponentials, we want to talk about kind of a couple new things that we're going to ask you as far as like graph characteristics. The first is end behavior. End behavior is basically what the y's are doing, okay? How are the y's acting as the x gets closer and closer to either positive or negative infinity. So as I kind of follow the graph way to the right, what's going on with the y's? Are they kind of leveling off at a number? Are they going way up to the sky off to infinity? Are they going way down to negative infinity? Okay, so basically as I go left, what's going on? Okay, am I going up, down, or kind of flattening off? Same thing as I go left, what's going on? Does the graph go up? Does the graph go down? Or is again the graph kind of level off, which we see a lot with asymptotes, okay, in exponential graphs. Second thing is that word asymptote that I'm talking about or just mentioned. We're going to look at horizontal asymptotes, which all exponentials have. A horizontal asymptote is basically a line that a graph approaches as x gets really big, as x goes to infinity, or as x gets really small, as x goes to negative infinity. Okay, so those are going to be a couple of key vocab words. We're going to ask you a little bit about them. I'm going to kind of show you what they look like graphically with a kind of a couple of just generic examples of some exponentials. All right. So if we looked at something pretty simple like y equals 2 to the x, really generically, without getting into too many of the points, which I plotted in the other video when we looked at this one, I'd go through 0, 1, and then basically the graph would shoot up. It would grow, and over here it would level off. Okay? Now the big reason why it levels off is from the properties of exponents worksheet that you had to go through. You take 2 up to like the negative fourth, that becomes 1 over 2 to the fourth, or 1/16. If I did something like 2 to the negative eighth, that would be 1 over 2 to the positive eighth. Okay? And I'm obviously not sure. Let's see, 2 to the fourth is 16, 32, 64 would be 6, 128 would be 7, 256 would be 8. So this would be 1 over 256. What you're noticing, though, as my x value becomes smaller and smaller, my y's become a small fraction, 1 over 256. Next one, 1 over 512, 1 over 1024. So what's going on is my x's become really small, my y's are getting closer and closer to 0. Okay? And that's what we're seeing with this graph, is that this graph is leveling off at a height of 0. Okay? And that's going to create our horizontal asymptote. Okay, so what we have is we have values that the y's are getting closer and closer to, or that the graph is kind of leveling off and approaching. That's what we call our horizontal asymptote. Okay, so our asymptote is going to be this line, y equals 0. Okay, so horizontal asymptotes are actually equations of lines that the graph look to kind of approach. Okay. So we're going to have horizontal asymptote at y equals 0. Our end behavior, EB, our end behavior, okay, our end behavior basically we got to look at both sides. One, we have to look as I go to the right, what's going on with the graph, and the other as I go to the left, what's going on with the graph. How we write that is we use an arrow. This says as x approaches. X approaches infinity. So as x approaches infinity, that means I'm moving to the right on the graph. So as I move right on the graph, notice I'm also going up. So the bigger the x, the bigger the y. 2 to the fourth, 16. 2 to the fifth, 32. Okay, these things are growing, and they're growing exponentially. They're getting large rather quickly. Okay, so that's why you see this big, steep rate of change on the graph. So the idea is as x goes to infinity, what's the y doing? Well, as we saw, as I go to the right, I'm also going up. So as x goes to infinity, y also goes to infinity. Okay? The symbol here is kind of sideways 8. That's our infinity symbol. So x approaches infinity is kind of what this is saying. Well, now I got to look what's going on as I go to the left. Well, as I go left, the x's are negative. So we're talking about as x goes to, or approaches, negative infinity. Well, as I go left, 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 as I talked about earlier, my y's are leveling out. They're getting smaller and smaller and smaller, and they're going to a value of 0. So as x goes to negative infinity, my y's go to 0. Okay? One of the things you're going to notice is there is an absolute direct connection between your horizontal asymptote and one of your end behaviors. So if, as x goes to either negative or positive infinity, if the y's seem to be approaching a number, meaning the graph flattens out, whatever number they approach is going to be the value of your horizontal asymptote. Okay? So that's what we're going to be looking for. All right, let me do another example quickly. All right, so I'm going to graph something like y equals 1/3 to the x plus 2. Well, as we should have seen in the other video, since 1/3 is smaller than 1, or between 0 and 1, it's going to be exponential decay. So it's going to come and kind of flatten out. And then I got this plus 2, which shifts. So I should have had a graph that looked like this. But because of the plus 2, I have to vertically shift this. I got to do that transformation. And so I'm going to shift this graph 2 units up. And the key thing is that moves that asymptote from being at y equals 0 up to y equals 2. So my new graph is going to look something like that. Still exponential decay, but again, I've shifted that graph up. Okay, so here's some key things. Horizontal asymptote. Horizontal asymptote is always going to be at this value that's being added or subtracted. It's going to be at that vertical shift. Okay, so whatever value that vertical shift is the equation of the horizontal asymptote. So if there isn't one, then it's always at y equals 0. And once we add something in there, it either becomes positive or negative, so whatever that value is. So my horizontal asymptote is going to be y equals 2. And behavior, well, as x goes to infinity, so as I trace this graph and x gets bigger and bigger, notice that my finger is flattening out. And it's flattening out at a height of 2 because it's approaching the horizontal asymptote. So as x goes to the right, as x gets bigger and bigger, the y values get closer and closer to 2. Mathematically, that makes sense. I'm going to multiply 1/3 by itself over and over and again. So 1/3 times 1/3 is a 9th, times 1/3 is a 27th, times another third is 1/81st. This is going to 0, and then I have to move it up 2. So it's going to get closer and closer to 2. So my end behavior as x goes to infinity, y approaches 2 on the right side. And on the left side, as x approaches negative infinity, well, now when I go to the left, follow the graph, left, left, left. Notice my finger's going up, up, up. So as x goes to negative infinity, which means I go to the left, the y's are going up to positive infinity. So y approaches positive infinity. Okay, so a couple little things that we're going to ask you about is the horizontal asymptote. Okay, basically a line that the graph approaches as x gets really big or really small. And then the end behavior, what's the graph doing? What are the y's approaching as x either goes to like infinity or negative infinity?